Hi everyone, I'm Anna Lisa Varri. I'm a UKRI Future Leader Fellow. This is my job title at the moment, which means that I have an academic appointment that is actually shared between the School of Physics and the School of Mathematics. And in practice, I would see myself as a mathematical astrophysicist, if such a thing exists.
Hi, I'm Dylan Robson. I'm a final year PhD student and I work up in the observatory doing X-ray properties of galaxies and clusters in the simple simulations. What inspired you to become a scientist?
I was never one of those people with a clear obsession for a subject, I think, or a specific trigger moment, I would say. But I have a memory from childhood, actually, that I think I reconstructed as one of the key moment of personal realization. And I think it was in elementary school when I was exposed to the existence, the teacher told us in class about Pythagoras' theorem. And this was just in a sort of a really elementary level kind of description. So it was just a statement and a few examples in which the theorem worked. And I remember that aspect, that sort of level of generality completely shocked me. So I don't have a memory of what happened afterwards. I just remember almost this physical sensation of power, almost overwhelming, in the sense that it was so general and so simple at the same time that really made a very strong impression on me. But apparently when I went home, essentially for 3 days straight, I continued to draw a right angle triangle and measure right angle triangles in my home, essentially going back to my parents and saying, it works even here, it works even on this case, it works all the time. So I think that this was clearly my sort of personal realization early in life, that there was a possibility of uncovering, or the existence at the very least, of those very deep truths, I would say, that were formal and yet really linked to the real material world. And subsequently, probably when I was a little bit older, to realize that it was possible to discover these things, in the sense that other human beings, like Pythagoras at the time, but many other after him, were actually able to find them out. And the idea of this element of possible understanding of simple facts that were so powerful really, really shocked me very deeply, actually. So when I was a teenager, I was kind of caught up with other level of obsession and decided that I really wanted to understand the origin of languages. So I ended up doing a high school that was with very little scientific content. And when I was at the decision moment for university, this is where I was really having to do some soul searching. And I think I went back a little bit at that decision moment to that initial sensation of powerful and scientific beauty. That was eventually what attracted me. To be completely honest, I think that I would have, if I had been more confident at the time, because as I said, I was really with very little background and I wasn't sure that I was able to survive through the university education in science with essentially a humanities background that I had at the time. If I had been a bit more confident, I would have probably done mathematics just because of that sort of appreciation for even the formal aspect. But I said, let's try physics because this sounds a little bit easier. I gave myself 1 year, and at the time I said, okay, if I do this, if I still enjoy, and if I survive 1 year of higher education there, maybe I'll continue. Otherwise, I'll revise and I'll do classics. And this was really my life plan at the time. After a year, I was still very pleased and I survived and I was happy, and that I continue since then, but always with a bit of this tension between physics and mathematics. And then I essentially discovered the existence of applied mathematics that in Italy, where I'm from, was having a very different sort of meaning in the spectrum of subject. And this is where I found myself very comfortable in the UK academic system and the sort of interpretation of subject. So this is really my story, which is a bit of an anomaly, I think.
You were sort of unsure on necessarily where you wanted to go at the beginning, but you did have this sort of drive to finding these deeper truths. And so you've kind of gone into why you went into maths. There's also this other aspect of you're doing mathematical astronomy, like you're saying, or astrophysics, sorry.
Yeah, no.
So where did that come into it? Was it sort of by coincidence, or was there something particularly interesting about astrophysics that really brought you in?
Well, I think it was into my bachelor's, really. There was some offering in theoretical physics. I think that in Italy still the education for physicists is very much a bit old-fashioned, so we tend to get a lot of mathematics taught by mathematicians. But I was finding theoretical physics in the sense of maybe theoretical particle physics less appealing, because I was seeing a lot of sort of beautiful applied math that was going into there, and maybe a lot of even technical aspects that were challenging but very appealing to me. But nonetheless, less appealing that some sort of, again, simple aspect of grounded understanding of reality. And where I found this kind of idea of using beautiful applied math with a link to simple problems was with a specific professor that was acting in theoretical astrophysics. So I was essentially driven by the way in which he was presenting this kind of simple truth and again, simple concept with an astrophysical context. And I ended up essentially deciding to work with this person for my bachelor thesis. And then I continue for my master and my PhD with this same person that was essentially having this very specific, and I said, possibly slightly old-fashioned take on theoretical astrophysics with analytical techniques as much as possible.
Do you see any sort of big discoveries or big changes coming in your field of work that might have a wider impact, not necessarily on just your field itself, but maybe the wider field or even potentially bigger?
Very good. Yes. This is, I think it's a soul-searching exercise that we should do on a regular basis as researchers. So there are sort of smaller questions that are very much intrinsic to my research program at the moment that do link to the broader picture, and then really the big picture question. So things that I would classify as smaller, but still big question and linked to the kind of things that I try to attack personally are, for example, related to the demographics of black hole populations, just to be specific to the astrophysical context. And in particular, one specific question related to this, and can we understand black hole, how they form, how they evolve, is linked to the sort of intermediate mass range. So we now have very established evidence that the small black hole, stellar mass size, exist. The big black hole are well, an established evidence for the professional community, and they have been recognized by 2 Nobel Prizes at this stage. So I think we can consider them as established. But the intermediate range is still essentially a land for discovery in an exciting way, because I think it's a stimulus for theories to try to come up with better way to try to establish their existence, or probe at the very least their existence in a more unique way than what we're trying to do now. And for experimentalists, in the sense of observers, essentially in this context, is to try to come up with stringent limits at the limit of what we can do in terms of different multi-messenger approaches for probing their existence there. And ultimately the synergy between the two professional types to eventually come up with a characterization. The bigger one, slightly bigger one, kind of growing into the landscape for vision, is related to the constituents of dark matter. So I think that this is an obvious choice for this, but I think it's genuinely an intellectual and almost moral imperative in the sense that we are really at loss in terms of experimental attacks for this from the perspective of the laboratory, or even earthbound essentially searches. They are still ongoing, and of course there is a lot of hope to try to at least move our bounds of our ignorance really in meaningful direction. But also in terms of the astrophysical evidence that so far is the one that seems to be most convincing, we need to, I think, try to be as creative as possible to try to exclude possible candidates, which is the typical approach that the community is taking now, and also try to just specify what are the genuine limit for where our theories can or cannot go. So my take on this is to try to look for dark matter or try to understand dark matter in the places where we are reasonably sure that there is none, and why it's not there. And finally, if I can suggest another sort of even more general point of discussion, is related not to a specific element on the sort of scientific landscape or physical landscape, but is related to our methodology as scientists. And in particular, having shared a little bit of my story, I really feel there is a tension between theory, numerical method, and experimental ones. And in particular, now that we are at the stage in which, in principle, computer facilities are allowing us to do even more powerful simulation with higher numerical resolution and more sort of details progressively, not to claim that we can resimulate the universe and say job done, but essentially we are tempted to have a numerical approach to our solution, to our problem, often and often nowadays. And experimentally, we have this avalanche of data that is coming our way from different observatories, different colliders, and progressively this big science approach. So in this changing landscape, where is the role of theory? Where the sort of small, simple idea, those sort of absolute truth are lying. And in particular, of course, many of these experiments and large sort of adventures are anchored on still fundamental principles. But can we allow, as a community and as a collective, we still space and time mentally to come up with the next set of simple basic truth? And where theory essentially is having a role in the scientific world, where there is this avalanche of information, and where can we complement essentially the searches approach and the idea of the discovery within a sea of data and this overwhelming power of simulation in terms of this simple yet general aspect of essentially the old-fashioned theory.
Progress of the academic career often feels like potentially sort of the amount of work or the focus of your work can change quite drastically as you step through. So how do you think your ability to approach those answers and sort of approach, maybe like almost approach your approach to this?
Yes.
So how has that changed throughout your career? So going from sort of maybe your undergrad to postgrad to now where you are now, how do you feel like your approach to this has changed or has been sort of most beneficial for you?
I think that at the beginning, especially, I, with some sort of rear view approach, see myself very rigorous in the sense that I was very skeptical about having proficiency to attack or allow myself to attack general question. So I was really keen to try to have simple problem that I was able to dominate, and where I was feeling comfortable, and where I was able to find an answer that was as exact as possible in the sense of the piece of paper type of approach. And this is where also my comfort zone was. And I was feeling very, I was really convinced that being professional was also being respectful of your boundary and not try to speculate in a less consistent way over area where you were not being educated enough. So of course, this was the mindset of my sort of younger version, and progressively you get exposed to more area of your field of study, more methodologies, and you grow confidence in yourself as well at the same time. I think the two aspects are correlated, or at least they were for me. And it's an ongoing process, of course. You always learn more. And this is one of the beauty of this profession and one of the real luxury, really. So progressively, I felt that it was allowing myself more freedom and more also just confidence to speculate a bit more or attack problem that I was seeing a bit at the boundary of my level of professionality, really. I'm still sort of battling with this feeling in the sense that I tend to be a person that do like to think on the broader perspective, but I'm really anchored to my primary area. And I feel that if I can devise a contribution to something else, it has to come from my area of high proficiency or at least expertise.
So in this way you can sort of approach this question and sort of science in general throughout your career, how that's sort of grown, and your sort of willingness to push these boundaries, like you say, has grown. Obviously, that changes your ability to actually go to this question. But is there any sort of specific period in this growth, or maybe even sort of place that you were, or physically, or even sort of mentally within within that journey, that you enjoyed particularly? Sort of, what was your favorite time or place in this scientific journey?
I have a few sort of strong memories and key moment, Pythagoras theorem style, in the sense of this almost, I wouldn't call it revelation, but things that gives you almost this physical sensation. And the first one, then of course you remember the first one, was really when I cracked the problem for my master thesis. And I think that this was the sort of level of almost high sensation in the brain that got me hooked for life. I went back to old papers on ADS, our repository that thankfully also offers you a copy of 30s, 40s, 50s, and 60s articles at your fingertip for free. So I stumbled upon Chandrasekhar, one of my personal heroes, really, a solution for a stellar structure problem that was completely different with respect to the kind of thing that I was trying to attack at the time that was related to stellar system. But nonetheless, the mathematics that he was using was exactly the one, and the sort of slightly complication in the problem that I was encountering that was preventing me to find the sort of clean solution that I was striving for was exactly the one that he was identifying. So I found those. Essentially, I pulled an all-nighter because I was completely hooked at that time over this specific set of articles where he was attacking this. I continue because that problem actually had a slightly longer history. And I found an approach a few years later from the Chandrasekhar initiation, where their problem was solved in a clean way with a slightly different mathematical technique, which I took, I applied to my case, and it worked beautifully. At that time, I remember it was, the sun was coming up through the roof of the place where I was staying at the time, still in Milano. And I saw this, and I was having my clean solution on the piece of paper. And I felt this is happiness. I want to do this for the rest of my life.
Is there any piece of advice maybe that you've thought of on your journey, or a useful piece of advice that was given to you on your journey that you would like to offer sort of PhD students who, or students in general? I'll start again. Is there any piece of advice that you'd like to offer PhD students or students in general that might be sort of starting out this career, or potentially even looking at going into the next step of the career, that you found particularly useful?
Thank you for asking this. Yes, I think I have three that I collected over the years. The first one is coming from my high school teacher in ancient Greek and Latin, so is from a different context. But I remember, and this really stayed with me in a general sense. She was telling me, because I was very, very caught up with the idea of translating and being as creative as possible through the translation process from ancient Greek in particular. That was my favorite subject at the time. And she was cooling me down a bit in a good way, saying, well, this is great, but please remember that you're just an interpreter. Don't get yourself too much convinced of your own position. If you're a theorist, don't assume that you need to force your model or your point of view onto the empirical data. And if you're an experimentalist, don't assume that you're able to read everything through nature and essentially have this in a completely blind way. So this is also a recipe when you're a little bit, I think, older, not to get your ego in the way or your favorite pet theory, as I was saying, and try to have a unbiased, agnostic as much as possible point of view with respect to the way in which you're approaching your work. The second one is another personal realization that came very late, I think, in my professional sort of development, which is science is made by people. This sounds very obvious and slightly cheesy again, but is just to say that we are still human at the end of the day. So we can be tired, we can be emotional, we can be completely dominated by irrational aspect. And ultimately, we are still filtering essentially through our human component that is unavoidable. So this aspect of don't sort of scrap humanities out of the picture and try to accept it with all the limitation that this entails. Don't assume that you need to be something or someone else with respect to who you are, in the sense of don't pretend to be something different or be interested in something different or be someone else with respect to what is your natural sort of inclination to be in terms of your scientific curiosity, the way in which you interact with others. Don't assume, especially if you're facing an open-ended question, that you need to give an established answer or that there is a established sort of way to show that you're professional. Don't hide yourself. As long as you're able to motivate your point of view, even if you see, if you feel that is unconventional, don't hide it, because usually this is what is of most interest on the other side of the bench, and they might be even learning from you perspective that otherwise would not be possible to identify. So don't pretend that you're different from yourself, and at the same time try to be as honest as possible, even in formal settings, in the sense of let your personal values come through, as long as you're able to justify them appropriately.